assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
So in this problem, we have the mass of an SUV, and we want to determine the mass of CO2 emitted when this vehicle accelerates from 0 miles per hour to 65 miles per hour. So the first thing we'll do is find out the kinetic energy this requires. So we'll take our 65 miles per hour and multiply it by 0.44704, which is the conversion factor in order to get our speed in meters per second. And so we have 29.0576 meters per second. Now we can find kinetic energy with the KE equals 1/2 mass times velocity squared equation. So our mass is 2,500 kilograms, and our velocity we just found. We square that, and that gives us a kinetic energy of 10,55430 kilogram meter squared over second squared, which is equal to 10,55430 joules. And so we'll just divide that by 1,000 to convert into kilojoules. So now we have our kinetic energy in kilojoules. And now we're told that this kinetic energy comes from 30% efficiency. So this is at 30%, and we want to find what it is at 100%. And so to do that, we'll take our kinetic energy and divide it by 0.3, that 30%, and that gives us the value at 100%, which is 3,518.1 kilojoules. And so now that we have that, we can determine the moles of octane by taking our number and dividing it by the heat of combustion of octane, which is 5,430 kilojoules per mole. And that gives us 0.6479 moles of octane, C8H18. So now we write the chemical formula for the combustion of octane. 2C8H18 plus 25O2 forms 18H2O plus 16 CO2. And so now we take our 0.6479 moles of octane and do a mole to mole ratio where we have 2 moles of octane for 16 moles of CO2, just our 2 here and our 16 here. And that gives us that we have 5.183 moles of CO2. So now in our final step, we'll take our 5.183 moles of CO2 and multiply by the molar mass, 44.01 grams per mole, and that'll give us 228.113 grams of CO2. And this will be our final answer for the mass of CO2 produced by this vehicle accelerating from 0 to 65 miles per hour.